Hello everyone, myself Saida Javeria. In this video, we are going to discuss about agent and environment. Here is the diagram where it shows the interaction between agent and environment, where it involves sensors, actuators, actions, and percepts. Starting with the structure of agents. How do the insights of agents work? And in addition, their behaviors. A general agent structure is agent is equal to architecture plus program. The agent program is used to implement the agent function to map percepts, that is input, from the sensors to actions, that is output of the actuators. It also requires some kind of approximation. It runs on a specific architecture. That is, the agent architecture is the computing device with physical sensors and actuators. For example, an ordinary PC or a specialized computing device with sensors such as camera, microphone, etc., and actuators such as display, speaker, wheels, legs, and etc. The next up we have is task environments. When thinking about building a rational agent, we must specify the task environments. That is the piece description, which stands for performance, environment, actuators, and sensors. Here is an example where the agent type, performance measured, environment, actuators, and sensors are given. Let us consider an example of an taxi driver. The performance measured are safe, fast, legal, comfortable trip, maximize profits, and correct destination. The environment is roads, other traffic, pedestrians, customer places, and countries. The actuator specifieds are steering, accelerator, brake, signal, horn, display, talking with passengers. Sensors such as cameras, sonar, speedometer, GPS, odometer, accelerometer, engine sensors, keyboards, etc. Next up we have is the structure of agents. The steps done under the agent architectures are sensors data, that is program inputs, also known as percepts. Next is program execution, and the next is program output, which is also called as actuators actions. There are different kinds of agent programs, such as table driven agents, which also doesn't work well. Next, we have simple reflex agents, model based reflex agents, goal based agents, and utility based agents. We have learning agents. For example, the taxi driver agent makes a quick left turn across three lines if traffic and has the conditions. The critic observes the shocking language from other drivers, and the learning element is able to formulate a rule saying this was a bad action. Then the performance element is modified by installing the new rule. Besides, the problem generator might identify certain areas of behavior in need of improvement and suggest experiments, such as trying out the brakes on different road surface under different conditions. We have episodic versus sequential agents, that is, the agent's experience is divided into atomic episode. The next episode doesn't depend on the actions taken in previous episode, depends only on episode itself. Example, spotting defective parts on assembly line in episodic, chess playing and taxi driving case are sequential. Next we have is static versus dynamic, where the environment can change while the agent is deliberating. Agent is continuously asked what to do next. Thinking means nothing. Example, taxi driving is dynamic. Other cars and itself keep moving while the agent details about what to do next. Crossword puzzle is static. There is also semi-dynamic agent, that is, the environment doesn't change, but the agent's performance score does. Example: just playing with a clock. Next is deterministic versus stochastic agents. Deterministic, we have the next state of the environment is completely determined by the current state and the agent's current action. Example: the taxi driving environment is stochastic, never predict the behavior of traffic exactly. The vacuum world is deterministic, but stochastic when randomly appearing dot. We have strategic, that is non-deterministic because of other agents' action. Coming up we have is goal-based agents. The action decision process involves some sort of goal information describing situations that are desirable. That is, combine the goal information with the possible actions proposed by the internal state to choose actions to achieve the goal. Search and planning in artificial intelligence are devoted to finding the right action sequences to achieve the goals. Next is fully observable versus partially observable. Fully observable, where the agents can access to the complete state of the environment at each point in time. Agent can detect all aspects that are relevant to the choice of action. Example: partially observable. A vacuum agent with only local dirt sensor doesn't know the situation at the other square. An automated taxi driver can't see what other drivers are thinking. The performance measure for rationality. Performance measure the embody the creation for success of an agent's behavior. Subjective or objective approaches. Objective measure is preferred. Like example in the vacuum cleaner world. Amount of dirt cleanup or the electricity consumed per time step or average cleanliness over time. Which is better? How and when to evaluate? The next step is task environments. Here are some of the examples specified of the task environments, such as crossword puzzle, chess with a clock, poker, backgammon, taxi driving, medical diagnosis, image analysis, part picking robot, refinery controller, and interactive English tutor, for which the states are given for the observable, deterministic, episodic, static, discrete, and the agents. Among them, the most hardest case is partially observable, stochastic, sequential, dynamic, continuous, and multi-agent. Here is the end of the video. Thanks for watching.